Alright, so this video is going to be part 9 of our sequences and series review. Okay, this video will be on power series. So we're pretty comfortable at this point with proving if a series converges or diverges, and now really we're just throwing x into the mix and then seeing what values of x will make something converge or diverge. Okay, so what a power series is: a power series takes the form the sum from n equals 0 to infinity of c sub n, okay, where c sub n is just like the coefficient out front of this x minus a, okay, and that's something like in terms of n, like this, the c sub n could be something like an n over n plus 1 or an n squared, or something in terms of n. Okay, so that's what we're talking about there. Now, next we have that x minus a to the n. So you see, we introduce that x, that's going to be our variable, okay? The value of x is going to determine if this series converges or diverges. Well, for most series, you have an infinite interval of convergence or something like that, or, you know, but anyways. So a, what are we talking about with our a? Well, that's where the power series is centered. And if you're not, I mean, basically what that's talking about, where a power series is centered, is where the approximation is most accurate. And that's something we're going to talk a bit about more when we talk about representations of functions as power series, okay, and the whole approximation there, and that's where this kind of comes in a little bit more, okay, where we have an a, that's going to show us where our approximation for that function is the most accurate. All right, but yeah, so we're going to do a quick example of just seeing what values of x are going to make a power series converge or diverge. We're going to work on radius and interval of convergence. So yeah. So here we want to see, like I said, what values of x will make this series converge. We have the sum from n equals 1 to infinity of x minus 4 raised to the n over n. Okay, so first, I mean, what types of tests are we using here? Well, those tests, you're either going to look at this as this maybe a geometric series. It's not here, but if it was a geometric series, then it's an easy tell. Okay, or you're going to use the ratio or root test. Okay, you're not going to use really any other test for this. Okay, so for instance here, how we're going to find out what values of x make the series converge, well, it's not all being raised to like the nth power or anything like that. We're going to use the ratio test. So let's do that. We're going to take the limit as n approaches infinity of, well, remember, a sub n plus 1 over a sub n. Okay, that will give us the limit as n approaches infinity of, well, a sub n plus 1, that's just going to be plugging in a n plus 1 for n, and you get x minus 4 to the n plus 1 over n plus 1. That's going to be all over x minus 4 to the n over n, right? Just your a sub n, which is right here. Cleaning this up a little bit, we get the limit as n approaches infinity, the absolute value of, we have a x minus 4 to the n plus 1 over x minus 4 to the n, and then we'll have a n over n plus 1. Okay, now we can do the limit of each of these separately, okay, and well, the limit of n over n plus 1, that's just going to be 1, right? So we don't need to worry about this piece right here, but what will this be here? Well, if you're dividing this out, you got to subtract the exponents, right? This is the same base here, so it's all good. You subtract the exponents and you're just going to get the first power, okay? So you're going to have an x minus 4, all right? So this equals the absolute value of x minus 4. Now for this to be convergent, okay, for this series to be convergent, this piece right here needs to be less than 1. Okay, that's what the ratio test says. All right, so now we can actually just figure out what values of x is going to make the series converge by doing this out a little bit further. Okay, so if you drop the absolute value signs, you're going to have an x minus 4 is greater than negative 1 and less than 1. Okay, and you're just going to add 4 on each side. So you end up getting that x is going to be between 3 and 5. So right here is our starting interval, okay? Now, since we're taking the ratio test, when the ratio test equals, when we get something that equals 1, right, when our limit equals 1, we know that the ratio test is inconclusive, right? So if we have a 3 minus 4 here, well, we're going to get the absolute value of -1, which is 1, right? And that will make that's the ratio test being inconclusive. The same thing if you plug in 5. Okay, so the ratio test doesn't tell us if we're going to have to include either of these endpoints. So what we're going to have to do is check them manually by plugging them into the series here. Okay, so let's do that. We are going to plug in 3 first. We get the sum from n equals 1 to infinity of 3 minus 4 to the n over n. Okay, that is the same thing as saying the sum from n equals 1 to infinity of -1 to the n over n. Now we know that that is the alternating harmonic series, and that's convergent by the alternating series test. So what this is telling us is that 3 is another value of x that will make the series converge. So that's going to be included in this interval here. Okay, well, let's check 5 here. Take the sum from n equals 1 to infinity of, now we're going to have a 5 minus 4 to the n over n. Well, that's just going to be a 1 to the n over n, which, well, 1 to any power is going to be 1, so we get the sum from n equals 1 to infinity of 1 over n. That's the harmonic series. Okay, it's not alternating, which sucks, but that's the harmonic series, and we know that diverges. All right, that's a p series where p is less than or equal to 1. It's, well, equal to 1 here, so that fits. Now, that means that that value of x, that 5 that we plugged in, is not going to make the series converge, so we're not going to include it in our answer. Okay, so our answer is actually going to be this right here, okay, from 3 to 5. You can also write that as bracket 3 comma 5 parentheses, okay, because we're including 3 and not including 5. Now this interval right here, this is called the interval of convergence. Okay, it's the interval, all right, that of x that makes the series converge. Okay, now there's also another term that we've went over, and that's the radius of convergence. Okay, and the radius of convergence can be found when you get down into that x minus a format. Okay, and that a, of course, is 4 here. You can even see it right there. All right, and your radius will be right here. Okay, this is your radius of convergence. Now, I have what I think might be an easier way, okay, because maybe you don't remember that. Okay, say that you don't remember how to find the radius of convergence that way, which I think was something I got a little tripped up on when I had the sequences and series test. How I found the radius of convergence was, okay, my interval is from 3 to 5. Okay, so let's write my interval here. I have some space right here. My interval is from 3 to 5, right? Now, the center of my interval is 4, and the radius of the interval is the radius of convergence. Okay, the radius of this interval is from, well, here to here, right? From the center to one of the endpoints. Okay, what's that distance? It's 1. Okay, so the radius of the interval of convergence is your radius of convergence. That's another way you can remember it. So, you know, whatever works better for you. As far as closing remarks go here, just make sure that you have a pretty good understanding of just of power series in general, because you're definitely going to need it for pretty much everything you do after this. You know, representations, Taylor and Maclaurin, and all that stuff, because you know this is huge. Okay, and especially understanding the interval of convergence, the radius of convergence, things like that. So that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left.
You can also view the playlist for sequences and series and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.